Hello friends, welcome to our channel Knowledge Amplifier. So in this particular video, we are going to start exploration of one very popular cloud lakehouse platform, and that is Databricks. Already in my previous video in the year 2020, I have covered this Databricks platform and how to create a free trial account and start experimenting with PySpark in it. If you want to have that prerequisite knowledge, you can surely check the link given in the description box. So in this particular video, we will try to launch Databricks from AWS Marketplace. Okay, and how to do that, what are the steps to be done on that, here in this blog, detailed documentation is available. So I'll be following this blog to create a Databricks account, and then we will perform various experiments with it. Okay, so as a first step, what we will do, we will basically subscribe to Databricks Data Intelligence Platform from AWS Marketplace. So I'll go to my AWS Management Console and I'll click on AWS Marketplace. If you are not able to find out AWS Marketplace, you can search here Databricks like that way, and here you will be getting an option of Databricks Data Intelligence Platform. So just click on that. It will take you to a new tab, and then here you can click on Try for Free. And then here it will take you to this page where it will ask you to subscribe to Databricks Data Intelligence Platform, and it might cost you little amount, so you have to consider this specific experiment might charge you a little bit, but you will have a good learning and that will surely help you in future. So I am going ahead with subscribe, and here you can see your subscription is in progress. You can now set up account on the vendor website. So here if you click on this, it will take you to the Databricks platform for creating a Databricks account. So if you scroll below, here you will be getting an option create account. So click on that, and when you create an account here, what will happen, that account will be integrated with AWS. Okay, so here you can see that it is continuously checking the status whether AWS and Databricks integration is completed or not. So here I will provide my email address. So here I have given all my details and click on sign up. And here you will see this tab, your AWS subscription was successfully linked. For next step, go back to your AWS Marketplace tab. So if you come back to AWS Marketplace tab, here you will see status is linked. Then click on next. You can choose AWS region where you want to launch your Databricks related stuffs. Basically one cloud formation template will be running. So for that I am choosing US is not a problem. Keeping all this as default, here I will acknowledge this one and I'll click on next, and then here I will launch the product. Okay, so here in the backend basically one cloud formation template will be running. So let's wait for a few minutes, and even by that time if you go to AWS Management Console, and here if you go to cloud formation, here you will able to see in the region something creation in progress. Okay, so basically it is launching the Databricks related stuffs like VPC, NAT, gateway, subnets and all our required IAM roles, policies, etc. It will be creating using this cloud formation template. So we have to wait until and unless this cloud formation template status convert to complete. Refresh and wait for a few more minutes. So here you can see cloud formation stack is complete. Now here maybe you can click on open Databricks again, and here it will be asking you these things. So I'll put my email address, and here it will send us a code, verification code in our email. So here the verification code I need to put. And here you will get the account level workspace. So here you can see one specific workspace got created by default. And if you check the VPC, this VPC is the same VPC what your CloudFront has created. Maybe if you go to resource, here if you search the VPC, here you will see that this cloud formation template basically created this VPC, IGW, etc. On that VPC only this specific workspace was launched. And here you will be getting the URL to open the workspace, or you can click on this also to open the workspace. So here this kind of Databricks UI will be coming up. Okay, right? Obviously, as we have done earlier, we can go to compute and we can click on create compute, and then we can start working with our Databricks notebook, which I will be continuing in my next session. So in this specific session, we have explored how to create a Databricks free trial account with AWS. You can follow the same steps to create a Databricks account using AWS and make the environment ready for hands-on experiments, which we'll be covering in our next session. Stay tuned. Now in this step, we will have quick hands-on on Databricks. Generally, how we quick start our Databricks or even Snowflake, if you consider that we should have a compute engine, right? Cloud warehouse, we can say. So I will click on create compute for our Databricks, and single node, that is fine for experiment purpose, and single user, single node machine also will work. That means this Databricks cluster will not be shared across multiple users. Only this user, Sodadru Mukherjee, will be using this. Okay. Runtime, let it be this one, or if you want, you can choose some latest runtime version, which will have some extra features in latest runtime. You can check the documentation link, not a problem, but I am keeping default one only. And then here, terminate after 120 minutes of inactivity. That one I can change to maybe 60 minutes of inactivity. That is fine. If you want, you can give some tags, and I will create the compute here. So it is going to take 2-3 minutes to launch our compute. So here you can see status. It is basically currently trying to create our instance. So let's wait for a few minutes. So till our cluster is getting ready, what we will do, we will duplicate this in a new tab. And here we can maybe click on new and then click on notebook. Okay. So meanwhile, I will show you some code base, what I have already written to start this quick start demo. Here you will get this kind of Jupyter notebook type console. And if you click on this folder structure, here as of now, only this notebook is available. So maybe I will open one notebook which I have already downloaded. Here I'll upload this one. And then Databricks Quick Start notebook I'll be opening. And this is the notebook. So I will quickly take you through the code base. And here you can see our compute is up and running meanwhile. So in the connect session, I will connect with the cluster so that notebook can use that particular compute engine. Okay. So as a first step, what I want to show you, just like Snowflake, we create external stage if our data is sitting in S3 or some other location. Similarly, in Databricks also, there is a concept of mounting. Okay. So you can consider Databricks as a local file system which is called DBFS, Databricks file system. In that Databricks file system, you can mount some external location that can be from S3. For example, here I have already created a bucket for this demo which is having this name, and where we are having 4 folders. In the input folder, we are having some files in it, and output in the output folder, for example, we want to write the process data and so on. So what I have to do basically is pointing to this bucket, I need to create one external stage, kind of if you try to find similarity with Snowflake feature. So for that, this is the code base. Obviously, you can use access key secret key based authentication between Databricks and AWS, or you can go for assume role IAM role based authentication. So because this is the first POC first demo, I am keeping it simple and showing you with access key secret key based authentication. So all you have to do is provide the secret details and then bucket name. So here I have given this bucket name, whatever it is having here, and then mount name. So like you can consider in Snowflake, we define external stage name, right? So similarly here we have to give the mount name. Okay. And then we have to execute dbutils.fs.mount command to mount this S3 external location to this Databricks local file system mount path. Okay. I will run this one, and here you can see this running, and it returned true. That means integration is successful. Now suppose you want to see all the files available in this external stage, like how we execute list command in Snowflake external stage, right? Similarly here, for this code you can execute to basically display. Using display command, we can display DataBricks DataFrame or pandas DataFrame, something like that. And then dbutils.fs, generally we use list to list all the folders or files available in a directory. So similarly at dbutils.fs.ls, and then you can provide the mount path. So mount path should always start with /mnt, then slash. Here the mount name we have given this one, that's what we have given here. And if we are executing display command, we'll able to see all the 4 folders, whatever are available already in our external stage, they are getting displayed, right? Input folder, output folder, product review input, product review output. That 4 folders, whatever is available. But if you see within our external stage, within input folder, there are some files also available. But that files, this command will not list. It will just list the parent level. It will not go recursively to subfolder level. Okay. So for that, here I can write a simple custom code that is list file recursive. And first I can execute Databricks dbutils fs.ls to get the current level folders and files. And if anything is directory in the current parent directory level, then I will again call this function to go recursively in it. And then I am passing my mounted path. So that way we can hope that this will basically give us all the files recursively along with the folder details. So if you see here input folder, within input folder we are having versicolor.csv, virginica.csv, etc. Then output folder and product review input, these 2 folders are available. Output folder is empty, that's why it is not having any files. But in the product review input, if you go here we are having a file, right? That if you see here, it is listing. And product review output is empty in our external stage. If you observe, product review output is empty. That's why it is not showing. So I hope this simple function is pretty much clear to you. Now it's time to read our input files. So here I have already uploaded some IDs dataset files in our input folder. So that I will try to read. So here if you see spark.read.format CSV option header true. Just like how normally we read any CSV folder data, just instead of S3 path, we have to give the mount location. Okay, so we have mounted the path Databricks external stage in the bucket level, right? Within bucket level, you can then mention subfolders to read specific directory. So I need to append input folder to read that specific folder location, and then I am executing df.show to get the data image. So here you can see this is running. So here Spark job is getting executed, and here it will beautifully show us the data frame, which is our popular IDs dataset available. Okay, cool. Now if you want to get from which files it is coming, you can obviously execute df.select.input file names, and then here you will see versicolor.csv and virginica.csv at the source. And if you see here within our input folder, we are having only these 2 files. That means it is working as expected. Now we can write this data frame data as a delta lake in output folder. So output folder currently, if you see in our S3 location, it is empty. If I refresh, still here you will see it is empty, right? Now what we will do, we will write the data whatever we have read from our input folder, which is in CSV format, we will write back in delta file format. Okay, so that's what syntax we have given. And save as table. So I want to create a table also in our Metastore, so that we can perform some SQL query on top of our data lake. So Metastore, if you want to check, here you will see a catalog option, and within our catalog, here we are having Hive Metastore, which is default. Within that, we are having default database you can consider. Within that database, we are creating a table with the name delta table 1. So Hive Metastore.default.delta table 1. As simple as that. So what it will do, it will basically write the data frame as delta data frame in this specific output folder. Okay, if you refresh, here you will see our delta log transactional log folder is created, along with that Parquet data written. Okay, these Parquet data are nothing but our IDs dataset data, what we have read as CSV file format from our input folder, right? As simple as that. And now if you refresh our catalog in Databricks within our Hive Metastore, within our default database, now this time you will be able to see delta table 1 is created. Like blue data catalog store, the table level details, schema information, etc. Similarly here Hive Metastore within default, here our table details are available. Okay, so if you want to query, you can obviously execute select star from Hive Metastore.default.delta table 1 and limit 10 to view the data. That way you can perform SQL query. Just you have to use %SQL magic command to execute any SQL query. Like in Glue notebook we were using %SQL. This time we have to only use %. As simple as that. Okay. Suppose you want to update some data in your Delta Lake, because Delta Lake support ACID transaction, so you will able to do from Databricks as well. Update complete table details with hive metastore dot default dot table name, set class name equal to upper of class name. So here if you see, initially it is class name having upper and lower case combined. Okay, but I want to convert everything to uppercase, so that's what transformation we have done, and all rows are impacted, all 101 rows. Why 101 rows? Because in our this specific table, if you see, select count star from this specific table, here you will be able to see it is having 101 rows only, right? And that all rows got impacted because in this update clause we have not given specifically any where clause or where condition. So as a result, here what we should see, that new Parquet files should be written. Okay, right here you can see new Parquet files are written. Some Parquet files are having timestamp 34, some are 35, so they are written newly. And in our delta transactional log also, here you will see that new transactional log JSONs will be created, right? I hope intuitively you are getting all this. And now suppose here this time if you execute select star from this table limit 10, here the difference what you will see, that all the class names are having now capital letters, because that's what update command we have executed. Correct? I hope up to this it is pretty much simple. Now what I want to show you, that just like Snowflake, Databricks also support various GenAI functionality. So for that, I have basically taken here one product review related CSV file. So as a first step, what I will do, I will create an external table pointing to this specific location. So here if you see, this is the simple command, create external table hive metastore dot default dot reviews. So reviews will be our table name. Here I am defining this schema using CSV file format, and then option header true because our CSV file is having header. And then to define this specific external stage, already till bucket level it is mounted, right? So mnt slash Databricks external stage, this is our mount path. Along with that, product reviews input, this is basically input folder name what we have given. So that way we can create external table very easily pointing to that specific S3 folder location. And now I can query select star from hive metastore dot default dot reviews limit 10. Here you will be able to see our product reviews dataset. And point to be noted, in our hive metastore here, this time two tables are available. One table already we have created, one table just now we have created based on review dataset, right? Here you will be able to see lot of reviews are there, like great mouse, smooth performance. So this is positive sentiment, right? Then next one, if you see, decent sound quality, but the bass is weak, expected better for the price. So it is a mixed sentiment, neither negative nor positive. Both things are available here. So suppose business team want to perform sentiment analysis on these reviews. Obviously, you can create some NLP model from scratch and all things you can do. But in this GenAI world, Databricks support GenAI functionality as well, using which you can do all these basic GenAI stuffs very quickly. So for that, all you have to do, you can use the SQL function AI analyze sentiment, and then you can pass any sentence to detect sentiment for that. Okay, like here if I am passing I am happy, this is a positive sentiment, so this particular SQL GenAI function will return positive. So the same function I can utilize on top of our reviews dataset to get the sentiment out of it, right? So another example I can provide, it's a very bad weather outside. So this is kind of a negative sentiment. So if I run this query, here you will be able to see it is returning negative. So that way it will work. Now you can apply this on our table also, like select star, comma AI analyze sentiment, and then reviews column, where our reviews data is stored, right? That column name is reviews. On top of that, I want to perform sentiment analysis. So that's what I have passed here as sentiment from our table. As simple as that. And if you check our new table, now sentiment column is added. The first one is positive sentiment. Obviously from here itself, human understanding, we can get that great mouse, smooth performance, and excellent battery life, highly recommended. So positive. If you check this one, noise cancellation is good, but the ear cuffs are a bit uncomfortable for long use. So that means both positive and negative are available. That's why it is throwing a mixed sentiment, right? Now obviously you can write this data in our S3 Delta Lake as well. So just execute this query using PySpark and then mention the S3 path where you want to write the data, and then using write.format delta, you can write the data in this specific folder. So product reviews output. So if you see here, we are already having product reviews output folder, which is currently empty. There we can write the data. Okay. So here it is running. And here it is completed. If I go back to this location, here you will be able to see our Parquet file and delta log folder is created. If you download this Parquet file and open any online Parquet viewer, so I'll choose my Parquet file. So here you will be able to see that same data is available, whatever we got in our data frame. That is sentiment column is also available. So this is how you can perform various operations in Databricks. This is just a primary quick start video what I wanted to cover. In our next section, I'll be diving deeper into Databricks various features which can be very helpful for data science and data engineering related workloads. So overall, it is having very much high similar features with respect to Snowflake. Like in Snowflake, what is external stage, in Databricks that is mount path. In Snowflake, what is cloud warehouse, in Databricks that is compute platform, right? Now, there are some more concepts you will find similarity with respect to EMR notebook as well. Like if you recall, in EMR by default, if you create any Hive table within EMR, then it use Hive Metastore, which is local to that cluster. So as a result, if EMR cluster goes down, that tables will no longer be accessible. That's why in EMR, for persistent Metastore, we use Glue, Catalog, or maybe some RDS cluster for Hive Metastore instead of using local Metastore, right? Because once cluster goes down, local Metastore will be going away. Same problem is available in Databricks also. This Hive Metastore, whatever table you have created, once you terminate this cluster, these metadata or schemas will no longer be available because this Hive Metastore is local to our compute platform. It is stored in our compute platform file system. So if compute platform goes down, although your notebook will be there, but all these tables will be deleted. So in our next section, eventually we will explore also that how to configure external Metastore, just like we configured earlier in EMR. So some features similar to EMR, some features similar to Snowflake, but overall an awesome platform for data engineering workloads, specifically for PySpark lovers like me. So I'll be keep on uploading features related to Databricks. If you have any doubt or any specific ask to cover any specific feature related to Databricks, feel free to ask in the comment section. I will try to cover or reply back ASAP. This is all for this video. If you find this video helpful, then please like, share and comment. Subscribe our channel if you have not subscribed till now. And don't forget to press the bell icon to get the notification of our latest videos. Thank you for watching.